Hey guys, hope you had a good weekend. Well, it's Monday and I'm not there, so I'm going to do a video for you, and we're going to do absolute value inequalities. So what I want you to do is turn to the notes page. We should have already formatted that last Thursday, and on the left-hand side, I want you to recall what we did for absolute value equations. So when it was an absolute value equation, if I had x plus 5 is equal to 6, I had to make my two equations, right? I said that x plus 5 is equal to 6, and then I said x plus 5 is equal to negative 6, because the inside of this can be negative, but we know absolute value can never be negative, so that's why it became positive. So I want you to recall that when we did equations, we made two new equations, right? When we did inequalities, we made two new equations and then we solved them. So I got x was equal to 1, and I got x is equal to negative 11, and then I put it in bracket form from least to greatest. Okay, that's what we did when we did absolute value equalities. Now what we're going to do is we're going to do absolute value inequalities. So it's very, very similar to the equalities. So now I'm going to pick you up and take you over here. Okay, so now we're going to go to our notes. Ooh, hope I don't drop you. Okay, so now we're here and I'm going to follow along with our notes. Can I see? Okay, so the main idea is that we're going over absolute value inequalities. This is very, very similar. And we have two cases. So we have greater than and greater than or equal to. And we know the difference between greater than or equal to and greater than. One has an equality sign, one does not. Okay, we've already done interval notation. So in example 1, I'm still going to set my absolute value brackets into two inequalities. But now watch what I do. I still isolate my absolute value, and then I branch it. So it's isolated, so now I can branch it, and I'm going to keep x is greater than or equal to 5. But watch what I do now. Now I'm going to say x is less than or equal to negative 5. So remember when we had the equality sign, it was a positive value and a negative sign. But now, not only do we change it to a negative, we also flip our sign. Okay? So x is greater than or equal to 5, and x is less than or equal to negative 5. When I graph that, we've already graphed one of these. So when we graph x is greater than or equal to 5, it's a closed circle, shade to the right. And when I graph x is less than or equal to negative 5, it's a closed circle and I shade to the left. So I've got two graphs on this one. This is the graph form. So interval notation, it's very similar to what we did last week. So if I start over here, it goes from negative infinity to negative 5, and I block it out. Or I have 5 to infinity. This is an or statement because the solution can be negative 8 or it can be 8. It can't be the same. So I have two separate equations. That's why it is an or statement. So that's case 1. Example number 2, I isolate my absolute. It's isolated. So now I have x is less than or equal to 8. And my new equation will be x is greater than or equal to negative 8. Remember, I flipped that sign as well as my negative. So now when I graph it, look what happens. Here's 8, and so I say x is less than. And here's negative 8, and x is greater than. And these lines connect. So this is one line. So interval notation, remember, interval notation is still reading the graph from left to right. So when I look over here at the left, I block it at negative 8, and then I block it at 8. So that's what my interval notation looks like. That's my graph. My written notation, for an or statement, this can be your or statement. We still want to go least to greatest, so x is less than or equal to negative 5, or x is greater than or equal to 5. That's my or statement. That's written. So a written statement, the graph, the interval notation. Here's my graph, here's my interval notation. Now pay attention to how I write my set notation. I'm dealing with one variable of x, and if you look at it on the graph, it makes a lot of sense. So here's negative 8, here's 8, and I know that x is less than or equal to 8, and x is greater than or equal to negative 8. So x is in the middle, my arrows face the same direction. I start with the least amount, negative 8 to 8. So there's my written notation, here's my graph, and there's my interval notation. So 3 things that I'm looking for on your homework and in your notes. The written notation, the interval notation, and the graph, okay? So when you look at this, does it look similar to something that we've already done? Yes, it does. What is this? All this means is that we have, it's not moving up. It's not moving up. Okay. Oh, there we go. Okay. All right, so what does this mean? It means that absolute value inequalities are really just compound inequalities. That's all that means. So now, any absolute value inequality that we do can either be an and statement or it can be an or statement, but they still are compound inequalities. So here are the steps to solve. Very, very similar to when we have equalities. Step 1, I had to isolate the absolute value expression. Step 2 is I created 2 cases. So don't worry about the KISS method. That never really made sense to me. But we set up the 2 cases. Step 3 is we solve both inequalities. And step 4 is that we graph the solution and write our answer in interval notation and written notation. So there are 2 different notations that we do along with a graph. Okay, so that's what I fill in my notes. Remember, when you're doing your homework and you're doing your notes, to go back and look at those steps. So let's do a couple together. We already did one as an example where it's just 1 inside. So let's take a look at number 3. Okay, so when I look at number 3, my absolute value is already isolated. So now I'm going to put it into 2 groups. I have x minus 1 is greater than 6, and I have x minus 1 is less than negative 6. And now when I solve, I add 1, x is greater than 7, and x is less than, add 1, is less than negative 5. So what I do is I graph them first. So I'm going to graph where x is greater than 7. It's an open circle. I shade to the right. X is less than negative 5, so open circles shade to the left. So now we have an or statement. So my written notation is going to be just like this, except I put it from least to greatest, and it's separated by the word or. So x is less than negative 5, or x is greater than 7. And I box that answer. I've graphed it, and my interval notation is negative infinity to negative 5. Or, and highlight this, because a lot of times students miss this word or, and you've got to have it on there. Or 7 to infinity. So that's my interval notation. All right. So let's scroll up, and let's take a look at number 6. All right, so on number 6, is my absolute value isolated? No, it's not. So that's my first step. So I'm going to add 1 to both sides. And I get the absolute value of x plus 3 is less than 6. Now that it's isolated, I can branch it into 2, and I get x plus 3 is less than 6. X plus 3 is greater than negative 6. So when I solve it, I subtract 3, x is less than 3, and I subtract 3, and x is greater than negative 9. So let's take a look at the graph and see what happens. Is this an and statement or is it an or statement? So I open circle and shade to the left on 3, and x is greater than negative 9, so it's an open circle, shade to the right. So when those lines come together, I know it's an and statement. So my interval notation is negative 9 to 3, parentheses on both sides. And my and statement, remember, it's easier if you write it above the graph. So I'm dealing with one variable x. It starts at negative 9, it goes to 3, and it's easy if I look this way. You can see that x is less than 3, and my arrows go in the same direction. So when I read it, this is saying that x is less than 3, and at the same time, it's going to be greater than -9, which is perfect. So I'm going to box that as my written form. Okay? Now, I want everybody to try number 7 and 8. So go ahead and pause this video, and then let's see if we get the same thing. Okay? So hopefully you had a chance to do number 7 and 8. So I have to isolate first, so I'm going to divide both sides by 3, and I get absolute value of 2x plus 8 is greater than or equal to 10. So now I can branch into 2, and I get 2x plus 8 is greater than or equal to 10, and 2x plus 8 is less than or equal to -10. So when I subtract 8 on both sides, I get 2x is greater than or equal to 2, x then is greater than or equal to 1. Subtract 8, 2x is less than or equal to -18, x is less than or equal to -9. I'm going to do my graph, see what it looks like. So here's greater than or equal to 1. So shade in, go to the right. Here's -9, close circle, shade to the left. This is an OR statement. So I can take what I have here, and I'm going to say x is less than or equal to -9, or x is greater than or equal to 1. I'm going to box it. That's my written notation. I've already graphed it, so my interval notation is -infinity to -9. Block. Do not forget to write the word or here. Or 1 to infinity with a parenthesis. Okay, so I have my written notation, my graph, and my interval notation. Now let's see how we did on number 8. So 8, you still have to remember your rule of what happens when you multiply or divide both sides by a negative when we deal with an inequality. Well, on number 8, I've got to multiply both sides by -2. So that tells me I'm multiplying by a negative, I must change my sign. So now I have the absolute value of 4x minus 8 is greater than or equal to 12. Did everybody get that first step? Okay, I multiply by -2, so I must switch my sign. Now I have my absolute value isolated, so I can branch into 2 equations. I have 4x minus 8 is greater than or equal to 12, and 4x minus 8 is less than or equal to -12. And now I can continue doing what I do. So 4x is greater than or equal to 20, x is greater than or equal to 5 when I divide by 4. I add 8 on both sides, additive inverse, so 4x is less than or equal to -4. Multiplicative inverse and divide by 4, x is less than or equal to -1. I'm going to graph it and see what my graph looks like. So it says x is greater than or equal to 5, x is less than or equal to -1. Okay, so this is an OR statement. So my written statement is fine. I'm going to have x is less than or equal to -1, or x is greater than or equal to 5. My interval notation goes from -infinity to -1, blocked off. Don't forget to write that word or block 5 to infinity. Okay? So one last one that we're going to do is number 10, and then hopefully you guys understand it, and then you can get started. How are we doing on time? Yeah, 13 minutes. Not bad. All right, so number 10, let's take a look. I got to isolate first, so I'm going to get rid of this 11, so I'm going to subtract 11 on both sides. Go ahead and pause it and try this number on your own if you haven't done so. So now I have 1/2 less than or equal to 4. And now I'm going to multiply both sides by 2. So I get absolute value of 4x minus 4 is less than or equal to 8. Now that my absolute value is isolated, I can branch into 2. 4x minus 4 is less than or equal to 8. And 4x minus 4 is greater than or equal to -8. When I add 4, additive inverse on both sides, I get 4x is less than or equal to 12. Divide by 4, and I get x is less than or equal to 3. Add 4 on both sides, additive inverse. 4x is greater than or equal to -4. Divide by 4, x is greater than or equal to -1. I'm going to graph it to see what my graph looks like. And x is greater than or equal to -1. And x is less than or equal to 3. So those lines come together, so I know it's an AND statement. So I have interval notation is going to be I started at -1 blocked off. I ended at 3 blocked off. I'm dealing with one variable of x. It begins at -1. It ends at 3. So x is less than or equal to 3. And then that arrow is going to be the same because if I read it backwards, it says x is greater than or equal to -1. So there's my written statement, my graph, and my interval notation. All right, so go ahead and start on your homework. Good luck, and I'll see you tomorrow.